Have you ever found yourself in the middle of like one of those debates where people have really strong opinions on both sides?
Oh, yeah, definitely.
It can be tough to sort through, right?
Absolutely.
Like, just as an example, the whole debate around whether smoking is really all that dangerous,
Right, right.
people have such strong feelings about it.
Yeah, they do. It can be hard to know what to believe.
So what we really wanted to do in this deep dive is kind of give you like a framework
Okay.
for how we know what we know,
Yeah,
especially when it comes to, scientific stuff.
that's a great goal. It's so important to understand the basis for those claims.
So before we get into, the specifics about the smoking debate, we're going to take a step back
Okay, I like that. Back to basics.
and really look at what science even is
Yeah.
and what a scientific fact means.
Yeah, that's fundamental because, those arguments about smoking, those have been around forever.
Oh, yeah.
And you've probably heard every claim under the sun, right?
Yeah.
But before we can even start comparing the different sides, like, does this make sense? Does that make sense? Right. We need to agree on what science itself even is.
Yes.
What makes something a scientific fact? That's the foundation. Then you can actually start assessing all those different arguments you hear.
Exactly. And to do that, we've gathered some pretty fascinating stuff.
Oh, cool.
So we're going to be looking at global studies, like some really big ones.
Okay.
Like the British doctor study,
Oh, wow, yeah.
the U.S. Surgeon General's report,
Classic.
those huge influential studies. We'll also zoom in on Indonesia specifically.
Okay, great.
We'll use data from Riskizas
Yes.
and the Global Adult Tobacco Survey
Okay.
to see, what's happening here.
Makes sense.
And to really get to the bottom of things, we'll look at the definitions of science and scientific facts.
Yeah.
We'll also talk about why some people believe things that, well, go against all the evidence.
Right. That's a big one. Why do those claims persist even when we have so much data?
Yeah, exactly. So we'll explore the whole world of misinformation
Okay.
and, those conspiracy theories that pop up.
Right. Those are always out there.
So what we really want you to walk away with today is, first, a solid understanding of how science is different
Okay.
from other kinds of claims,
Yeah, yeah. There's a real difference.
And then second, a clearer picture of the whole smoking debate.
Absolutely. Arming people with the knowledge to see through the noise.
Exactly.
Yeah.
We want to give you the power to, decide for yourself
Yeah.
what information is credible.
Love it.
So how we'll do this is we're going to lay that foundation first.
Okay.
So we'll define what science is, what a scientific fact is, nice and clear.
Love it.
Then we'll look at all that evidence about the dangers of smoking
Okay.
from those international and Indonesian studies.
Great.
And then finally, we'll tackle why those claims that go against the evidence exist in the first place.
Right. Why those persist.
Yeah. So, ready to jump in?
I am. Let's get to it. Let's start with the basics. What is science at its core?
I love that you started there because it's so fundamental, right?
Oh, yeah.
And a lot of people think of science as just a bunch of facts in a textbook.
Right. It's like a static thing you just memorize.
But it's way more dynamic than that.
Oh, yeah. Way more.
It's a whole process.
It is.
It's a way of finding things out about the world around us.
Yeah. It's a journey. It's a process. It's about asking questions.
And it's not just about, rocks and plants and stuff.
Right. Right.
It can be about living things.
Yeah.
It can be about how societies work, all sorts of things.
All kinds of things. And what's really at the heart of it is this idea of observation and experimentation.
Testing things out.
Exactly.
And it's not random, right?
No, not at all. And that's what's so important about this scientific method.
Okay, yeah, let's talk about that.
There are key characteristics of the scientific method. The first, and maybe the most crucial, is that it has to be empirical.
Okay, so that's a word we hear a lot, empirical.
Yeah.
What does that actually mean in, plain language?
So empirical basically means it's based on evidence you can see, touch, hear, measure, quantify somehow.
Got it. So it's not just about, feelings.
No, no feelings.
Or opinions.
No, opinions don't count in empirical evidence.
It's about stuff that's, real.
Real, tangible data. You can verify it.
Okay, so it's grounded in what we can actually experience.
Exactly.
What's another important part of the scientific method?
Another really crucial element is that science has to be objective.
Okay, objective.
Yeah, which means minimizing bias.
So you can't just, see what you want to see.
No, you can't just see what you want to see. Scientists try really hard to look at the evidence without letting their own beliefs get in the way.
Okay, that makes sense.
And really importantly, other people should be able to check your work.
Okay.
So other scientists should be able to look at your evidence
Mm-hmm.
and ideally get similar results.
So it's not just one person's, like, interpretation.
Exactly. It's about minimizing that subjectivity. What else? It's systematic.
Okay, systematic.
Yeah. The scientific method, it's not just random. It follows a logical series of steps.
Okay, walk us through that.
You start by observing something.
Okay.
You notice something interesting. You ask a question about it.
Okay.
Then you form a hypothesis,
Which is like a...
which is like a well-informed guess,
Okay.
an educated guess about what might be happening.
Okay.
And then you make predictions based on that hypothesis. You think, okay, if my hypothesis is true, what should I expect to see?
Right.
Then you got to test those predictions, you do experiments, you make more observations,
Okay.
and then you analyze all the data you collect,
Yeah.
and finally you draw a conclusion.
So it's a process.
It is. It's
Okay.
methodical, step by step.
Yeah, it's not just jumping to conclusions.
No jumping to conclusions in science.
You got to go through those steps.
Yeah.
All right, now this next one is really interesting. Testable and falsifiable.
Oh, yes. Testable and falsifiable. This is so important.
So break that down for us.
Okay. So for something to be considered scientific, you have to be able to test it.
Okay.
You have to be able to design an experiment or make observations to see if your idea is actually supported by evidence.
Okay, that makes sense.
But then the other side of the coin is that it has to be falsifiable.
Okay, now explain that one.
Okay, so falsifiable means there has to be a possibility, at least in theory, that your claim could be proven wrong.
Okay.
If no amount of evidence could ever disprove your idea, then it's not truly scientific.
Can you give us an example?
Yeah, so imagine I say there's an invisible dragon living in my garage.
Okay.
An invisible, intangible dragon.
Right.
Now, no matter how hard you look, you're never going to find it, right?
Right.
And if I say, well, it's invisible, of course you couldn't see it.
Yeah.
There's no way to disprove that. It's not scientific because there's no possible evidence that could ever show it's wrong.
Got it. So a scientific idea has to be open to being, like, disproven?
Exactly. Exactly. It has to be willing to be challenged.
Yeah.
Okay, what else?
What other characteristics are there?
Reproducibility is key.
Okay, reproducibility.
So when a scientist does an experiment, gets some results,
Yeah.
other scientists should be able to repeat that experiment,
Well-
maybe in a different lab, different time, slightly different methods even,
Yeah.
and get similar results.
Yeah.
That consistency really builds confidence in the findings.
So it's not just a one-time thing.
No, it shouldn't be a fluke. All right, and then there's this understanding that scientific knowledge is tentative.
Tentative. Does that mean science is, like, unsure?
No, or not reliable.
No, not at all.
Okay.
Tentative simply means that what we currently understand scientifically
Yeah.
is based on the best evidence we have right now.
Okay, so as we get more information.
As new evidence comes along, and it always does,
Yeah.
science can change.
Okay.
That knowledge can be revised, updated, so it's not like set in stone.
No, it's not dogma. It can even be completely overturned in some rare cases.
Wow. Okay, so it can be pretty big changes sometimes.
It can be big changes, but that's how science progresses.
Got it. So it's not about having all the final answers.
Right. It's about constantly refining our understanding.
Okay, that makes sense. And then lastly, we have peer review.
Oh, yes. Peer review is so important.
How does that fit in?
Peer review is like quality control for science.
Okay.
So before a scientist's work is published in a journal,
Yeah.
it's reviewed by other experts in the field.
Okay.
And they really scrutinize it. They look at the methods, the data, the conclusions.
Let's make sure it's...
To make sure it's sound, ethical, credible.
So it's like having another set of eyes on it.
Exactly. It's like a panel of experts double-checking the work
Yeah.
before it's shared with the wider scientific community.
Okay, so to sum up, science isn't just about the facts themselves.
No, it's not a list of facts.
It's about how we arrive at those facts.
Exactly. It's about the whole process of thinking, investigating, and double-checking, triple-checking our understanding of the world.
Which brings us to, like, what are scientific facts then?
Yes.
Yeah.
That's the natural next question. If science is the process, then what are the products of that process?
Yeah, like what are we aiming for?
Exactly. So scientific facts, they're basically observations about the world
Okay.
that have been confirmed again and again through that scientific method.
Okay.
And they've gone through rigorous testing,
Hmm.
verification. They're accepted as quote unquote true
Okay.
by the scientific community, at least at this point in time.
Okay.
So they are based on direct observation or measurement. Like you can literally see them happen or measure them.
Give us some examples of those.
Okay, so water freezes at 0 degrees Celsius at standard atmospheric pressure.
Okay.
The Earth revolves around the sun.
Right.
These are things we can observe directly.
Yeah.
And we've measured them so many times, we're pretty confident about them.
And it's not just a one-time thing. Right?
No, definitely not. Scientific facts have been verified repeatedly by lots of different researchers using different methods, different places, different times.
So there's a lot of agreement.
There's broad agreement. There's consensus among experts.
Okay, so when we talk about a scientific fact, it's not just someone's opinion.
Oh, absolutely not. It's not just a hunch. It's based on lots and lots of solid evidence.
And you also mentioned that these facts can be kind of specific or more general.
Yes, exactly.
Give us an example of a more general one.
A general scientific fact would be something like, smoking significantly increases your risk of developing lung cancer.
Okay.
That's not just one observation. It's a conclusion drawn from decades of research across different populations using different methods.
Okay, so that's a good segue to our main topic today.
Yes, it is.
But before we dive into that, I want to touch on something you mentioned earlier.
Okay.
About the difference between facts, hypotheses, and scientific theory.
Oh, yes. Good point.
We talked about hypotheses as being educated guesses. But what about scientific theories?
Right.
Because in everyday conversation, theory can just mean like a random thought.
Yeah, like a hunch. I have a theory about who ate the last cookie.
Exactly. Exactly.
So
is that how it's used in science?
No, not quite.
Yeah.
In science, a scientific theory is something much, much bigger.
Okay.
It's a comprehensive explanation of how or why things happen in the natural world.
So it's not just one fact.
No, it's a whole framework that brings together lots of different facts.
Okay.
Observations, hypotheses that have been well tested.
So it's like this big overarching explanation.
Yes, it's like a big, well-supported model that explains a lot of things.
Okay, can you give us some examples of that?
Yeah, think about some of the really big theories in science, like the theory of evolution by natural selection.
Right.
Or Einstein's theory of general relativity.
Okay.
Or the germ theory of disease.
Yeah.
These are not just guesses. They are super well-supported explanations.
Right.
They explain a huge range of phenomena, and they've been tested over and over and over again.
So they're not like, oh, I have a theory that it's going to rain today.
No, not at all.
It's a much bigger, stronger.
They're much more powerful than that.
Okay.
They tell us why species change over time,
Yeah.
how gravity and space-time work,
Okay.
why we get sick from germs.
So these theories are actually like the peak of scientific understanding,
Exactly.
not just the starting point.
Yeah, they're built on a ton of evidence.
Okay, so with that in mind, let's look at the statement. Smoking is dangerous to health and causes diseases like lung cancer, heart disease, and COPD.
Okay, good one.
Where does that fit in our framework?
Based on everything we've talked about, that statement is a scientific fact.
You're saying that very confidently.
I am.
So tell us why.
It's a fact because we've seen it over and over again in countless studies,
Okay.
especially what we call epidemiological studies, which look at patterns of diseases in big populations over a long time.
Okay.
And it's also been confirmed in controlled lab experiments,
Okay.
where they can actually see how the chemicals in cigarettes damage cells,
Yeah.
cause inflammation, and mess up normal bodily functions.
So it's not just based on like one study
No.
or a small group of people.
This is a conclusion based on mountains of evidence
Wow.
from all over the world, from decades of research.
And to really show how strong that conclusion is, let's look at some of that evidence.
Okay, yeah, let's get into the specifics.
Let's start with those international studies.
All right.
The British Doctors Study.
That's a classic.
This study, it started in 1951.
Wow, that's a long time ago.
It was done by Sir Richard Dall and Sir Austin Bradford Hill.
Yeah, giants in the field.
It's considered like a foundation of epidemiology.
Yeah, a cornerstone.
So what they did was they followed around 34,000 male doctors in the UK.
Wow, that's a big group.
Yeah, and they followed them for 50 years.
50 years.
That's incredible.
From 1951 to 2001.
Wow, that's commitment.
And the type of study it was, it's called a prospective cohort study.
Okay, what does that mean?
So it means they enrolled these doctors before any of them had the diseases they were looking at.
Okay, so they were starting healthy.
Yeah, relatively. And then they followed them over time to see who got sick.
I see.
And they tracked their smoking habits.
Makes sense.
So after all that time, what did they find?
What did those 50 years of research reveal?
Well, first, it showed without a doubt that smoking causes lung cancer.
Okay, no question about it.
Yeah, and it also linked smoking to heart disease
Hmm.
and COPD,
Which is...
which stands for chronic obstructive pulmonary disease,
Okay,
which includes things like emphysema and chronic bronchitis.
right.
And one of the most striking findings was that smokers, on average, lose 10 years of life
10 years.
compared to non-smokers.
Wow, that's a significant chunk of time. But, and this is important, they also found that quitting smoking at any age had big health benefits.
Okay, so it's never too late to quit.
Yeah. And to add to the credibility of this study, it was funded by the UK government's Medical Research Council.
Oh, so it wasn't influenced by, like, the tobacco industry.
Exactly. It was independent research.
Okay, that's important to know.
And then we have another huge one.
Okay.
The U.S. Surgeon General's report on smoking and health.
Oh, I've heard of that one.
Yeah, this was from 1964.
Okay.
It was a turning point.
Yeah, it felt like a big moment.
And this wasn't just one study. It was a review of thousands of studies
Wow.
that had been done up to that point.
So a massive overview of the research?
Yeah. And they had this independent committee of experts
Okay.
who went through all this data.
To see what the consensus was.
Yeah. And their conclusion was very clear.
What did they find?
Smoking causes lung and laryngeal cancer in men.
Okay.
And it was probably the cause of lung cancer in women. They also said that smoking was the main cause of chronic bronchitis.
Wow.
And later reports, they kept building on this,
Okay.
adding more and more diseases to the list.
So the evidence just kept piling up.
Yeah, things like heart disease, stroke, other cancers, problems during pregnancy.
It's amazing how much we've learned since then.
And this report really changed how people thought about smoking.
And it led to a lot of those anti-smoking policies we have now.
So we've got all this evidence from around the world.
Yeah, the evidence is global.
But what about Indonesia?
Right, let's zoom in on Indonesia.
What do studies and data from here tell us?
So we have some very important data here in Indonesia as well.
Okay.
One major source is Riset Kesehatan Dasar,
Which is also known as...
Riskesdas.
Okay.
It's a nationwide health survey
Okay.
done by Balitbanks, which is the research and development arm of the Ministry of Health.
Okay.
And this survey collects a ton of health data
Okay.
from all over the country, including information on smoking, how many people smoke, and the rates of what we call NCDs,
Which stands for?
non-communicable diseases.
Right.
So things like heart disease, stroke, cancer.
The kind of diseases that are often linked to smoking?
Exactly. And what Riskesdas has shown us over and over again
Yeah.
is that there's a really high number of smokers in Indonesia,
Okay.
especially among men.
Okay.
And the data also shows that we have a big problem with NCDs here.
Okay, so there's a connection there.
There's a strong correlation. Now, Riskesdas isn't designed to definitively prove cause and effect, like the British doctor study,
Okay.
but the connection is clear.
Yeah.
Smoking behavior and these diseases are linked in the Indonesian population
And Riskesdas is really important because...
it gives us this national picture of health
Okay.
and helps to inform health policy in Indonesia.
So are there other data sources from Indonesia that we should know about?
Absolutely. Another really important one is the Global Adult Tobacco Survey,
Okay, what's that one called for short?
GATS.
Okay, GATS.
GATS Indonesia. This is a standardized survey
Okay.
done all over the world,
Okay.
coordinated by the WHO.
World Health Organization.
Yeah, and the CDC.
The U.S. Centers for Disease Control and Prevention.
Right. And it's been done in Indonesia, too, with the most recent data from 2021.
And what did that data show?
So the GATS data shows us, again, really high rates of tobacco use in Indonesia,
Okay.
especially Kretek cigarettes, which are very popular here.
Right.
It also highlights the problem of secondhand smoke,
Okay.
you know, in homes, public places, workplaces.
Yeah.
And one interesting thing it found was that there's a gap
Okay, between what?
between people knowing that smoking is bad and them actually being able to quit.
So people know the risks, but...
Quitting is hard.
Yeah. And what's a key strength of GATS?
GATS is great because it lets us compare across countries
Yep.
and see how different tobacco control policies are working.
So we get a global perspective.
Exactly. And then you also mentioned, you know, specific academic research.
Yeah.
Being done here in Indonesia.
Yeah.
Universities all over the country are doing studies
Okay.
that look at the relationship between smoking and certain diseases in the Indonesian population.
Okay.
Like, they might study the link between smoking and COPD
Okay.
in a particular hospital,
Right.
or they might look at the connection between smoking and heart disease in younger Indonesians.
Okay.
And again, these studies are finding the same thing as the global research.
So we have this huge amount of evidence
Mountains of evidence.
from international studies, national surveys, and specific research here in Indonesia.
It's all pointing in the same direction.
But sometimes we hear about, like, conflicting studies or information that seems to contradict all of this.
Right.
Are there really credible studies out there that say smoking might not be so bad?
This is such an important point.
Yeah.
Because this is where a lot of confusion comes from.
Right.
But I want to be completely clear. There is no credible, independent scientific research that says smoking is not harmful.
Okay, so there's no real debate in the scientific community.
The scientific community is very clear on this. Smoking is extremely dangerous.
Okay, so where do these claims of conflicting studies come from?
They usually come from a few different sources.
Okay.
One of the biggest historically, and unfortunately it's still happening today, is the tobacco industry.
Right, big tobacco.
They've spent huge amounts of money, billions of dollars, to fund their own research
Okay.
or support think tanks and organizations.
And their goal is to?
Their goal is to create doubt,
Oh, okay.
to make people unsure about the dangers of smoking.
So to protect the profits?
Exactly. They want to keep selling cigarettes.
Okay.
And we know this because of internal documents
Right.
from the tobacco industry itself
Wow.
that have come out through lawsuits and investigations.
So it's been proven that this was their strategy.
It was a deliberate strategy to mislead the public. And a lot of those industry-funded studies, they weren't very good quality.
Okay.
They had problems with their methods.
Oh, yeah.
And there was a clear conflict of interest.
Okay.
They were biased.
So what's another source of these claims?
Another tactic is what we call cherry-picking data.
Okay, what does that mean?
So it means taking a tiny bit of information from a big study
Okay.
and ignoring the rest of it.
To make it look like.
To make it look like there's a contradiction,
Yeah.
like pointing to one cold day in summer and saying global warming isn't real.
Right, so they focus on the exceptions, not the overall trend.
Exactly. And sometimes there's just plain old misinterpretation
Okay, that's...
of complex scientific research.
Yeah.
You know, some of these studies can be pretty complicated
Yeah.
with lots of statistics and jargon.
Yeah.
So someone without the right background might not understand it properly.
Okay, so they might draw the wrong conclusions.
Exactly. And then, of course, we have conspiracy theories.
Oh, yeah, those are always around.
A listener actually mentioned one about Big Pharma.
Okay, what was that one?
The idea that drug companies are exaggerating the dangers of smoking.
Okay.
So they can make money selling medicine to treat those diseases.
So that's a pretty common one, right?
Yeah, it comes up a lot.
What do you say to that?
Well, first of all, there's no real evidence for this.
Okay.
There's no serious research that supports the idea of this massive conspiracy
Okay.
involving, thousands of scientists and doctors and public health organizations all over the world.
Keeping it a secret for all this time.
It just doesn't seem very plausible.
Yeah, it's hard to imagine that many people keeping a secret.
And then think about the motives.
Okay.
If Big Pharma really wanted to make money from sick smokers,
Yeah.
wouldn't they want to keep people smoking?
Right.
But a lot of these companies also make products to help people quit smoking.
Okay, like...
Nicotine patches, gums, medications.
So that doesn't really sit with the conspiracy theory, does it?
Not really. It seems like they're trying to address the problem from both sides.
Okay, and also, let's not forget who the real villain in this story is.
Right.
Big Tobacco.